In this lesson, we continue uh, other tests for the determination of convergence or divergence of series. First, we talk about alternating series, and for some alternating series, we have a test to determine convergence or divergence. First of all, let me give examples of alternating series. For example, sigma of -1 to the power of k plus 1 times 1 over k as k runs from 1 to infinity is an alternating series. What does that mean? It is alternating. Like if I want to write down the terms of this series, when k is 1, -1 to the power of 1 plus 1, -1 to the power of 2 is 1, and 1 over k is 1. So the first term is 1. But the second term is, if k is 2, the power of -1 becomes 2 plus 1, which is 3. -1 to the power of 3 is -1 times 1 over 2. So it is -1 over 2. The third term is plus 1/3. The fourth term is -1/4, and so on and so forth. So this is an alternating series, meaning that the sign of the terms, like the first one positive, second one negative, third one positive, fourth one negative. So it goes back and forth between positive and negative. Let me give another example. Sigma of -1 to the power of k, 1 over k squared. And k runs from 1 to infinity. This is also an alternating series. When k is 1, -1 to the power of 1 is -1 times 1 over 1 squared, so it is just -1. But the second term, which is when k is 2, -1 to the power of 2 is 1, and 1 over 2 squared is 4, 1/4. So I can keep going using the same pattern, -1/9 plus 1 over 16, minus, plus, minus, plus, so on and so forth. This is another alternating series. So whatever the sign of a term is, the sign of the next term will be opposite. If one term has a positive sign, the next term has negative. If a term has a negative sign, the next term will be positive. For some alternating series, we can apply a test which is called alternating series test to determine the convergence. So let me mention that here, alternating series test. So let's have a series sigma of -1 to the power of k or k plus 1, it doesn't matter. Anyway, it makes it alternating. Times some term, we call it bk. And k can run from 1 to infinity or from any other integer to infinity. And these bk's are positive. But -1 to the power of k plus 1, depending on k, sometimes positive, sometimes negative, which makes this series an alternating series. So let this be an alternating series. Under two conditions, we can be assured that the series will be convergent. So if we have these two conditions, one, These BKs are they form a decreasing sequence. So BKs, so this series of BKs is a decreasing sequence. What is the meaning of a decreasing sequence? Meaning that every term is bigger than the next term. The next term is smaller. As we go further ahead, the terms of the sequence become smaller and smaller. So these BKs form a decreasing sequence. This is one condition. And two, the limit of bk as k tends to infinity is going to be zero. Meaning that these bk's, they go down all the way to towards zero. So if we have these two conditions, we can conclude that then the alternating series sigma of -1 to the power of k plus 1 bk is convergent. So if we have those two conditions, for sure the alternating series is convergent. Let's see an example. Determine the convergence or divergence of sigma of -1 to the power of k plus 1 times 1 over k. K runs from 1 to infinity. Is this series convergent or divergent? So these 1k, the sequence of 1k's is a decreasing sequence because as k becomes bigger and bigger, 1 over k becomes smaller and smaller. And this is an alternating series because it goes back and forth, or the sign of the terms go back and forth between positive and negative. So using the alternating series test, this is convergence. So just the explanation of why it is convergent. So using the alternating series test, it's convergence. As we saw in the first example, this series, in fact, is the series of 1 minus 1/2 plus 1/3 minus 1/4. So plus minus, and the general term, disregarding the sign of that, will go down to 0. So using alternating series test, this is a convergent series. It's interesting because, as a reminder, do you remember the harmonic series that sigma of 1 over k, k runs from 1 to infinity, is divergent using like the p series test. It's a p series with p equals 1. So the same series that is divergence, sigma of 1 over k, when we make it alternating, we multiply to each term -1 to the power of k plus 1, then the result becomes convergence. So this is divergence, but with that coefficient of -1 to the power of k plus 1 becomes convergence. So it's possible that some series with just positive terms is divergent, but when it becomes alternating, it is convergent using the alternating series test. But sometimes both of the two series are convergent. I mean, with alternating terms or without alternating terms. For example, sigma of minus 1 to the power of k plus 1 times 1 over k cubed as k runs from 1 to infinity. Is it convergent or divergent? It is convergent. Why is it convergent? Because again, this is an alternating series, and 1 over k cubed is a decreasing sequence. So this is convergent by the alternating series test. However, we know that as a reminder, if I ignore minus 1 to the power of k plus 1, just I consider sigma of 1 over k cubed. K runs from 1 to infinity is also convergent. Why? Because it's a p series, and so it is p series with p equals 3. We know that if it's a p series and p is more than 1, the series is convergent. So here both the alternating version of the series and the series itself both are, and the series with only positive terms, both are convergent. In the previous example, sigma of minus 1 to the power of k plus 1 over 1 over k is convergent. It's an alternating series, and it satisfies the conditions of the alternating series test, so it is convergent. But sigma of 1 over k is divergent. But here, both of these two series are convergent. There is an important terminology that I need to mention that here. Something like this, sigma of minus 1 to the power of k plus 1 over 1 over k, this is convergent, but if I look at the absolute value of that series, which is sigma of 1 over k, it becomes divergent. In this situation, we call the series conditionally convergent. Let me make this definition here. Let sigma ak, there is no assumption that AKs are positive or negative. They could be anything. K runs from 1 to infinity, be a series. So no other condition on this series. Part 1, if sigma of absolute value of AK is convergent, then sigma AK is called to be absolutely convergent. By the way, there is a theorem which says that if sigma of absolute value of k is convergent, sigma of ak is also must be also convergent too. And part two, if sigma of absolute value of ak is divergent, but sigma of ak without having absolute value sign is convergent, then we call sigma an to be conditionally convergent. Let me make this a little bit, this last word a little bit more clear. We call it conditionally convergence. So if sigma of absolute value of a series is convergent, we, the series itself is called to be absolutely convergent. But if sigma of absolute value is divergent, but sigma of the, or the series itself is convergent, then we call the series to be conditionally convergent. So we should be careful about this definition. Let me give an example. Sigma of -1 to the power of k plus 1 times 1 over k is, what do you think? Is it absolutely convergent or conditionally convergent? So we know that sigma of -1 to the power of k plus 1 times 1 over k using alternating series test is convergent, but by putting absolute value, that -1 to the power of k plus 1 disappears. We just have sigma of 1 over k, which is divergent. So therefore, this is conditionally convergent. Why is it so? One more time. Because the series itself, the series sigma of -1 to the power of k plus 1 over 1 over k is convergent by which test? By alternating series test. But if I look at the absolute value of sigma of absolute value of this series, absolute value turns all the negatives into positive, so it gives us a sigma of 1 over k, which is divergence. We have seen this before, that the harmonic series is a P series with P equals 1 and is divergent. So the series, the given series is convergent, but sigma of absolute value of the terms of that is divergent. So that's why it is conditionally convergent. So the reason here was, so because the series itself is convergent, but the series with absolute value is divergent. Or sigma of -1 to the power of k plus 1 times 1 over k squared is, what do you think? Is it conditionally convergent or It is absolutely convergent. As you might have correctly figured out, it is absolutely convergent. Why is it so? First of all, the series itself, sigma of -1 to the power of k plus 1 over 1 over k squared is convergent. Why is it convergent? By the alternating series test. And sigma of absolute value of the terms, which is just 1 over k squared, is also convergent. As I mentioned, there is a theorem if the sigma of the series with absolute value is convergent, the original series is also convergent. So let me repeat that. If sigma of the absolute value of the terms is convergent, then we can conclude that the original series is also convergent. One of the reasons that we talk about or we mention the definition of absolutely convergent or conditionally convergent is because of the next two important tests to determine convergence or divergence of series. One of them is called the ratio test, and the other one is called the root test. So let's see what the ratio test is. And then we do an example to clarify this. So let sigma of AK be a series. And let R be this limit, the limit of, as k tends to infinity, of the absolute value of this ratio. A k plus 1, which means that the k plus 1th term, when we do examples, that will be more clear what we mean here, over AK. So suppose R is the limit as k tends to infinity of AK plus 1, the k plus 1th term, over AK, over the kth term. If R happen to be less than 1, if this limit of the absolute value of this ratio is less than 1, then sigma of AK is absolutely convergent. And we have already talked about what is the meaning of being absolutely convergent. If R happens to be more than 1, then the series of AK is definitely divergent. And if R equals 1, then its ratio test doesn't help. Ratio test is inconclusive. By inconclusive means we cannot get any result using the ratio test. Let me move this word inconclusive a little bit to the left. All the letters can be seen. Is inconclusive. Of course, in this form, this ratio test is not very clear unless we see example. Consider this series sigma of 1 over k factorial as k runs from 0 to infinity. I hope you remember what factorial is from our elementary courses. And then use the ratio test to determine the convergence or divergence of the series. So let's expand this to see that a few of terms. The first term, k star from 0, 1 over 0 factorial. Do you remember what is 0 factorial? Some students, they think that 0 factorial is 0. No, 0 factorial is 1. So the first term is 1 over 1, just it is 1. The second term is 1 over 1 factorial, but 1 factorial is again 1. 1 over 1 is 1. So both 0 factorial and 1 factorial are equal to 1. The next term, 1 over 2 factorial. 2 factorial is 2, so 3 factorial is what? 1 over 6. 3 factorial is 6, right? 1 times 2 times 3 is 6. 4 factorial, 1 times 2 times 3 times 4 20 is 24, so 24, and so on and so forth. These are some of the terms of this series. So I want to use the ratio test, meaning that I want to find this R, which is the limit as k tends to infinity of absolute value of ak plus 1 over ak. First of all, since all the 1 over k factorial, they are positive, I don't see anything like minus 1 to something. I don't need to worry about the absolute value because everything here, all the terms are positive. What is the meaning of ak plus 1? It means that if this general term is ak plus 1 is just replace k by k plus 1. So it's going to be 1 over k plus 1 factorial. So ak is 1 over k factorial. Therefore, ak plus 1 is 1 over k plus 1 factorial. And ak in the denominator is 1 over k factorial. Let's calculate this limit to see that we get something less than 1 or more than 1. Or if it is equal to 1, the test is inconclusive. Doesn't get us anywhere using this test. But let's see if we get something less than 1 or more than 1. If I simplify this fraction, 1 times k factorial goes to the top, and 1 times k plus 1 factorial goes to the bottom. Before applying the limit, can you simplify that fraction k factorial over k plus 1 factorial? What is k factorial? It means 1 times 2 times 3 until we multiply by k. We go as far as k. 1 times 2 times 3 dot 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 times k. What is k plus 1 factorial? It means that, again, 1 times 2 times 3 up to k plus 1. But before getting to k plus 1, we have k, then k plus 1. Now, can you simplify this? Of course we can, because all of these and all of these are the same. All the multiplication from 1 to k, I see it on the top and at the bottom. So the only thing that we have is the limit as k tends to plus infinity of 1 over k plus 1. What is this limit? When k tends to infinity, at the bottom, infinity plus 1 is infinity, and 1 divided by infinity is 0. Let's look at the ratio test. The ratio test says that if I get something less than 1, the series is absolutely convergent. So I got 0, and 0 is less than 1. So by ratio test, the series is absolutely convergent. Okay, let's do another example. Please try this on your own. So use the ratio test. To determine convergence or divergence of sigma minus 6 to the power of k over k factorial as k runs from 1 to infinity. So I should look at the limit as k tends to infinity of the absolute value of the k plus 1 term. I mean ak plus 1, ak. So it's going to be the limit as k tends to infinity, absolute value of the k plus 1 term is in this general term of the series. Wherever you see k, replace it by k plus 1. So you will have minus 6 to the power of k plus 1 over k plus 1 factorial. This is ak plus 1. Ak is minus 6 to the power of k over k factorial. how does the absolute value affect this fraction? All the negative disappear because here absolute value of -6 becomes +6. So if I want to apply the absolute value, the top becomes 6 to the power of k plus 1 over k plus 1 factorial. The bottom becomes 6 to the power of k over k factorial. Now let's simplify this fraction. The product of these two goes to the top. So 6 times k plus 1 times k factorial will be on the top, and the product of these two goes to the bottom, which is 6 to the power of k over k plus 1 factorial. So how can we simplify this? 6 to the power of k plus 1 over 6 to the power of k is just 6. 6 to the power of k plus 1 is multiplying 6 how many times by itself? K plus 1 times. 6 to the power of k is multiplying 6k times by itself. That's why when we simplify, 1k remains on the top. The other one, similar to the previous example, k factorial over k plus 1 factorial is going to be 1 over k plus 1. So this becomes the limit of 6 over k plus 1 as k tends to infinity. As k tends to infinity, the bottom becomes infinity. 6 over infinity is 0, and 0 is less than 1. Therefore, the series is absolutely convergent. Another example. Again, please try this on your own before watching my solution. Use the ratio test to determine convergence or divergence of sigma of 2 to the power of k over k to the power of 5 as k runs from 1 to infinity. So again, I suggest that you try this on your own before watching my solution. So we look at, so R, which is the limit as k tends to infinity of ak plus 1 over ak. So this is the limit as k tends to infinity. Ak plus 1 means in the general term, replace all the k's by k plus 1. So this becomes 2 to the power of k plus 1 over k plus 1 to the power of 5. Ak is 2 to the power of k over k to the power of 5. Since all the terms are positive, this absolute value doesn't do anything, so I can ignore absolute value sign. And if I simplify that fraction, 2 to the power of k plus 1 times k to the 5 goes to the top. and 2 to the power of k times k plus 1 to the power of 5 goes to the bottom. This ratio 2 to the power of k plus 1 over 2 to the power of k is just 2, because 2 to the power of k plus 1 means that I'm multiplying k plus 1 copies of 2 by each other. But 2 to the power of k means I'm multiplying k copies of 2 by each other. So far I have the limit as k tends to infinity of 2 times k to the power of 5 over k plus 1 to the power of 5. Any suggestion for that ratio k to the power of 5 over k plus 1 to the power of 5? As you know from algebra, I can think of this. So both the top and the bottom have the power of 5. So this ratio to power of 5. But k over k plus 1, when k tends to infinity, is 1. Why? Because as we have seen before, and you have seen even in Calc 1, we keep the term with the highest power from the top, which is k, and the term with the highest power at the bottom, which is also k. So k over k is 1, and so the limit, this limit as k tends to infinity, this tends to 1. So as k tends to infinity, k over k plus 1 tends to 1. And 1 to the power of 5 is still 1. There was a 2 here, so this is going to be 2. And since 2 is more than 1, look at the ratio test. Since if r is more than 1, the series is divergent. Therefore, the series is divergent. The next test that we need to know is the root test. Let me first write down what the root test is, then we see an example. Let sigma a k be a series. Let rho, the Greek letter rho, be this limit, the limit as k tends to infinity of the kth root of absolute value of ak. To distinguish this limit from the limit in the ratio test, we use rho here. But for the root test, for the ratio test, we use R. Again, we have three possibilities to decide about this the series. If rho is less than 1, then the series is sigma ak is absolutely convergent. Excuse me. Absolutely convergent. If rho is more than 1, the series is divergent. And if rho is equal to 1, then the root test is inconclusive. Let's see an example. Use the root test to determine convergence or divergence of this series. Sigma of 2k plus 1 over 5k minus 1 to the power of k as k runs from 1 to infinity. So here, what is AK? What is the general term? This is AK. This is the general term of the series. So when I want to apply the root test, I should look at the limit as k tends to infinity of the kth root of AK, or absolute value of AK. The limit as k tends to infinity of kth root of absolute value of 2k plus 1 over 5k minus 1 to the power of k. If there was a term like minus 1 to something before the general term, then the absolute value will make that negative disappear. But here we don't see that, so there is no need to the absolute value. As you know from basic algebra, the kth root of a positive thing to the power of k, just these two cancel out. So k and k cancel out. So what I have is the limit as k tends to infinity of 2k plus 1 over 5k minus 1. What do you think this limit is? As you know, since k tends to infinity, I keep the term with the highest power on the top, which is 2k, and the term with the highest power at the bottom, which is 5k, as k tends to infinity. So k and k cancel out. So just let me cross on the case, not the coefficients. So this k and this k, they cancel out. So the result is 2/5. Obviously, 2/5 is less than 1. Therefore, the series is absolutely convergent or converges absolutely. Another example, use the root test to determine convergence or divergence of sigma k to the power of k over 100 to the power of k as k runs from 1 to infinity. So on the top, I have k to the power of k. At the bottom, I have 100 to the power of k. Let me make this more clear. At the bottom, 100 to the power of k. So in fact, The kth term is like this, k to the power of k over 100 to the power of k. As usual, I suggest that you try this on your own before watching my solution. So the limit is what? As you know, we call this limit rho for the root test. Let me is the limit as k tends to infinity of the kth root, sorry, the kth root of absolute value of kth term, k to the power of k over 100 to the power of k. Since all the terms are positive, there is no need to the absolute value. If there was a negative before the fraction, that absolute value um, makes that negative disappear. And what is kth root of k to the power of k over 100 to the power of k? Using basic algebra, this is going to be equal to, so let me keep the limit sign. Kth root of k to the power of k is just k, and kth root of 100 to the power of k is 100. When k tends to infinity, infinity over 100 is still infinity. Infinity is not a number, but obviously it is something more than 1, right? It's not a number, but still it's more than 1. So therefore, by using the root test, the series is, if rho is more than 1, the series is divergent.